Dear students, Assalamu alaikum and welcome to another demo of this course of digital signal processing. In the previous demo, we've already seen how we can install CCS on our desktop computers. In this demo, we are going to see how we can actually program and control one of these kits. These are the kits which are available in our department, and we are going to see how we can use CCS to actually write a program that can control some of the peripherals of these devices. So stay along and happy learning. I hope you learn a lot of new things. So this time what we are going to do is look at how we are going to create these programs. So first of all, let's start off by creating a new project. So we go to the file menu, new CCS project, and over here we are going to say that let's give it a name, my test project. And then what we got to remember is from here the target, we've got to select our kit. So as we are already working with DSK6713, so it has automatically selected it. Otherwise what you can do is simply type in 6713, it will give you the two options, and you can go ahead and select DSK6713, and from the connection you have to select this connection, which is Spectrum Digital DSK EVM EZP onboard DSP emulator. Remember this thing that we have already looked at these things when we saw how to install code composer on our system. The next thing that we are going to do is simply select a basic example, which is hello world, and say okay, finish, and it is going to start a new project in which it is going to create a file which is hello world. So what this is going to do is simple. It's a very exactly C-like syntax in which it has included the header file, and it has created a main in which it is only written down hello world and then returning a 0 so that it finishes it off. So if I run this program, I should be able to connect with my DSP kit, run this program on the DSP kit, and see on the terminal that it has actually executed that program. Basically, these print kind of commands, obviously they are not printed on the DSP kit, but after communicating with the DSP kit, it's displayed on your screen so that you can do some system checks if you want to see what is going on with the inside your DSP kit. So let's go ahead and compile this build project. Everything seems to be fine. Now we can go ahead and debug this thing, and this is going to try to connect with the kit. It is connected and it has come to this breakpoint, and I can go ahead and say okay, step over, and this should actually print the hello world, and I want this thing to, and which means it is working perfectly fine, and I'm happy with my first program. Next thing that I'm going to do is I'm going to actually start writing a program in which I'm going to blink one of the LEDs. So what I'm going to do is simply go ahead and copy these configuration files, and I should be good to go. I don't need to type them again. I can simply go ahead and copy paste them over here. There we go. And let's go this way. So all that it is doing is it is going to toggle this LED number 0. I can actually change this to LED number 3. Okay, so what we want to do is have a look at these functions, that what these functions are doing. So all these functions are declared in these files, which is DSK6713_LED. Let's go ahead and have a look at the header file. So this header file is giving me, this is a typical type of programming in which you create a header file and a accompanying CPP file. And what happens in these header file and CPP files is that header file only contains the declaration of the function, whereas the CPP or C file contains the actual implementation of the functions. So we can see that this file gives me 4 different functions. One of them is first of all initialize the LED. So what this is going to do is turn all of them off. I can go the other way, I can turn all of them on. The other two functions are turn LED off, LED on, and then it is going to do the toggle. So what this as an input, it is taking the LED number. So as I showed you that this DSP kit has 4 LEDs, so we have to give it a number. So whether it is a 0th LED, first LED, second LED, or third LED. So what we want to ensure in these codes is that if the number goes beyond 4, somebody writes number 4 or 5 or 6, so it should give me an error. So let's look at the actual implementation of these functions. So this is the initialization function. So all that it is doing is it is resetting all the registers, all the LEDs to 0. So this is already written, the LED state is 0. So that means all of them are going to be turned off. The other two functions turned off and turn LED on and LED off. So it's quite obvious. All that it is doing is off is going to turn it to 0, on is going to turn it to 1. That's all that we are going to do. And specifically related to the LED number, but whatever the LED number is, we are going to turn it off or on respectively. So LED toggle. So in LED toggle, what we are doing is simply checking the number of the LED. If it is beyond 4, or if it is equal to or beyond 4, it should give you an error. Otherwise, all that it's going to do is check in this. It is going to check whether it is 0. If it is 0, then it is going to turn it on. If it is off, it is going to, if it is turned off, it is going to turn it on, and if it is already on, it is going to turn it off. So that's all the function of the toggle function. So that should actually run our program, and let's see if we can run this program. So what's going to happen is that as soon as I'm going to try to compile it, it is going to tell me, okay, I cannot find the LED configuration.h or many other files and libraries. So with every compile, I'll hit an error, and then I'm going to find what is the solution for that. So let's go ahead and try to compile this thing, and it gives me an error and tells me that LED configuration.h file, it cannot find this file. So to find this LED configuration.h, what I have to go to is to go on my desktop. I have placed a folder over here that contains these files. So these are the header files. So I need to copy these header files. Then I need to go to the my computer, go to the users, Ali Hassan, this workspace in which I have created my project. I need to paste these files over here. So after pasting these files, I'm going to recompile and see if I get any other error. Yes, I do get error. So that is for std.h. So this header file it cannot find. So this is a standard header file which is part of this my installations. This is already installed. So I'll show you the path of this file. So this is the path of this file where you can find this std.h. So what we have to do is include this path into my compiler. So what I'm going to tell this thing is to go into the build setting, go to the compiler, go to the include option, and add a path. So this is the path that I'm going to give it. Okay, go to this path and you should be able to find this library. I said okay, and it should be able to compile for this library. It should be able to find this library now, and let's see what happens now. Okay, so it has been able to go ahead, but it has given me some other error. It has given me that this cannot find this file. So for this csl.h, I know where it is. So let's write it down, which is path to csl.h, which is, I can find it over here. I go to my computer, it is in my C, it goes to the program files, these CSL include, these are the libraries which are part of it. Oops, Control C. So for my record, I keep it over here, and then I'm going to add this path into my compiler. So now the compiler should be able to find this csl.h. Let's go ahead and see where it has come. So it has come to some other place where it says that I cannot find this file DSK6713 LED. I know where this file is. So what I'm going to do is keep a record of this path so that I can share it with you guys. I will say path to this file, and I know where it is. So for that I have to go to my computer, C TI. I place all of those files over here, so they are in this folder. So this is the DSK underscore LED.h and C file. So I'm going to go ahead and copy this path and keep it as a record, and go ahead and add it into my build settings. There we go. Okay, and I want to compile it again and see what happens. So it tells me that it has been able to do most of the things, but it has found some undefined symbols. So that is happening because it is not being able to find the library. So what happens is that you must have learned in programming in C++ that when you create your specific proprietary code, what you do is that you create a C file, you create a header file. So header file contains the declaration, C file contains the implementation, and you can also create a library file which actually contains the complete implementation of those functions. But you do not expose those functions to the user. You only expose the utility but not the exact implementation. So that's why what you do is you need to go ahead and copy the library file. So get the library file, copy the library file. So for that I know where the path is. So it is in this library. So this is the library file that I need to copy. So I just copy this path for the record. There we go. And I'm going to copy this library path and place it in my project folder. Okay. So for that, it automatically CCS automatically creates the project in your parent directory. So this is my test project, and I'm going to paste this library over here. DSK6713 BSL.library. Now I should be able to compile this code. Yes, it has been able to compile. It is giving me a few errors regarding some warnings regarding some missing PI vendor section, but that is fine. I should be able to run my program, and if I run my program, I'm going to record it on my mobile phone so that I can share it with you later on. So what it should do is it should actually first turn all of the LEDs to 0, and then it should actually start blinking the LED number 3. So let's go ahead and run this program. So I'm going to run it on this program. Okay, when I execute my program, I can see that the LED number 3 is turned on, but it is not blinking as I had expected. It is turned on constantly, and the reason behind this is because I am toggling it without any delay. So what I need to go ahead and do is to add delay in my code, so that once the LED is turned on, it gives a delay of, let's say, 200 milliseconds, and after that it turns it off, and then again keeps it off for a few hundred milliseconds and then turns it on, so that we can see the LED blinking. So for that, what I have to do is I need to add some small code into it. So what I'll do is simply add some delay so that it actually counts till a few milliseconds, let's say 200 millisecond before it actually turns the LED off or on. So let's go ahead, and you can see on my screen I've added the delay of few hundred millisecond, and now when I compile and run my code, that should actually allow me to see the LED blinking now. There we go. Now you can see that the LED is blinking. I can actually increase the delay to make it even slow, or I can decrease the delay to make it blink faster. So let's stop this code and increase the delay and see what happens with the LED. So there we go, we have run this code. So you can see it is taking much longer to turn on and off now. Okay, next thing what we are going to do is we are going to change this LED to this one. So for that, all that I have to do is simply tell my code to, instead of toggling over here, instead of toggling LED number 3, I want to toggle LED number 0. So that will switch the LED, and then what I'm going to do is I'm going to use these dip switches to control one of these LEDs. For that, we'll have to do some coding. So let's stop this and we'll get back to the coding once again. So we have already seen how we can toggle LED on the DSP kit. So now let's try to control one of the LEDs using the toggle switches which are available on this DSP kit. So what we are going to do is write a piece of code that will allow us to control the LEDs using one of those switches. So let's go ahead and just write that code. So let's first write some comments over here. So what we're going to do now is controlling the LEDs through the toggle switches. So this is what we are going to do. So we are going to use one of the toggle switches on this DSP kit and use that to control the turn on and off the LEDs. So this is quite a simple task, but the things that we have to do is we have to write some if and else conditions. So what we are going to do is if DSK6713 underscore DIP underscore get. So this is what we're going to do is get the status of dip switch number 3, and we're going to check whether it is equal to 0. If it is equal to 0, so what we're going to do is turn on the LED number, you can give it a number, LED number 3. If the else, what we're going to do is DSK6713 underscore. So first what we need to do is turn off the LED number 3. So this is what we're going to do. If the dip switch 3 is equal to 0, we are going to turn it on. If it is going to equal to 1, then we are going to turn it off. So the command for that is DSK6713, the command that we've already seen, underscore LED underscore on, and we have to give the number of the LED. So this is the LED number 3, and then what we are going to do is we are going to tell it on else condition DSK6713 underscore LED underscore off. So this is all the command that we need to do is just write an if and else statement that on if, check the status of dip switch number 3, and if it is equal to 0, good. If it is not equal to 0, then we can go ahead and turn off the LED. So by just using these few pieces of code, we should be able to control the LED using the dip switches. Now let's go ahead and run it on our DSP kit. So we have written the code in which we are blinking the LED number 0. This is turning on and off after every 200 milliseconds. So after every 200 milliseconds, it checks the state of the LED and toggles it. And then what we have done is, just by writing few pieces of code, a few lines of code, I'm trying to control this, use this switch number 3 to control this LED number 3. So if I push it down, this LED should turn on. And let's see what happens if I push it down. There we go, this LED turns on, and if I pull it back up, I can turn off this LED. So I can control, just by using writing these few lines of code, I can control this LED using this dip switch. So what I'm going to do now is make a few changes into this code, and let's say that I'm going to blink this LED number 2. I'm going to control this LED number 0 using this dip switch number 3, and let's make these changes in our code. Okay, so we have decided that we're going to blink the LED number 2. So all that we have to do is tell it that we want to blink the LED number 2, and then what we want to do is we want to look at the dip switch number 3 and control the LED number 0. So let's change these things, make these appropriate changes in our code so that we know what we are doing. So that should be able to resolve everything. So we have changed the LED. So LED number 2 is going to blink now, and then based upon the dip switch number 3, it is going to turn on and off the LED number 0. So that should be good, and we can compile and execute this code on the DSP kit. There we go. So let's switch to the mobile phone camera so that we can do the recording of the DSP kit. So we can see here that by just making few changes in our code, now the LED number 2 is blinking, and now by using this switch I should be able to control the LED number 0. There we go, we can now turn on and off the LED just by using this dip switch. So these are just very small experiment and simple experiments in which we have been able to control our few functionality of our DSP kit using these either blinking, turning on and off these LED lights, or by controlling these LED lights using these switches. This is just to let you know that when you start learning these things, you start off with the baby steps, in which you start, the first thing that you learn in programming is the hello world program, and then you probably learn the for loops just to see whether you can run print the hello world program, hello world line by 3-4 times by using the for loop, and then you start making the complex program. So we have started off with very simple things, and in the next demos what we are going to do is try to take the input using these audio channels, take the input from the mic and give the audio back to the speaker, and then we'll try to do some digital signal processing on the audio that we are recording. So I hope you have enjoyed this demo and you have learned a few things. Best of luck, and wait for the next video. In today's demo, we have seen how we can run some of the programs and write code in CCS to control these DSP kits. In next demo, what we are going to see is how we can actually write our own program by ourselves and see what are the hurdles that we have to face to get our program running on these kits. And as you know, and I have previously mentioned to you guys, that it's not very straightforward and easy to control these kits, and it takes a bit of effort to get these kits running. So in this demo, we have just seen how we can run these programs, whereas in next demo we'll actually write this program and see all the hurdles and all the things that we have to do to run the programs. So stay along and we'll be back.